So we can see, Sarah, you can see the slides correctly? Okay. I think it's when I remind George that we need to record. George, you will show me when it started?
Yes, it started. We're ready to go.
Okay, good. Okay, so hello everyone. Bonjour à tous. George Gedenadis, Sarah Gannon, and Ariel Figov, and myself, Chantal Buteau, are delighted to welcome you to the online seminar series on programming in mathematics education. We wish to begin today by acknowledging this land where the Fields Institute for Research in Mathematical Sciences is situated, and from where we are hosting this event. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and most recently, the Mississaugas of the Credit River. Today, this meeting place is still the home to many indigenous people from across Turtle Island, and we are grateful to have the opportunity to be hosting our online seminar series from this land. Today is the fifth seminar from our series. We will hear from Dr. Ricardo Scucuglia from Brazil. I wish to highlight that in addition to the very insightful and rich seminar presentations we've been hearing, you can find additional resources on our website. We've put there the recordings of the seminar presentations, but also additional resources that have been recommended by our speakers. For example, materials for teachers on coding and mathematics, and also, for example, related research papers that are complementing or related to the seminar presentations. All this recommended by our speakers. We welcome everyone. We invite everyone to go visit this webpage. And if you have anything else you think you would like to see on this webpage, we invite you to contact us and to let us know, and we will see if we can complement the webpage according to your suggestions. We are grateful for the Mathematics Knowledge Network hosted by the Fields Institute for Research in Mathematical Sciences and the Social Sciences and Humanities Research Council of Canada for the financial support that makes possible hosting this event. The schedule for today is very similar to what has been in the previous seminars. That is, we'll first have a short introduction of the speaker by Sarah. Ricardo Scucuglia, ensuite, that's a big mix, will then present to us for about 45 minutes, leaving us with about 25 minutes for questions at the end, which will then be moderated by Sarah. And we'll finally have a short conclusion at the end of the session. Sarah, please.
Okay, good morning or hello everyone. So it's my privilege to introduce to you today's speaker, Dr. Ricardo Scucuglia. So Ricardo Scucuglia is an assistant professor at Sao Paulo State University in Brazil. Since 2000, he's been a member of the research group in Informatics, Other Medias, and Mathematics Education, or GPIMEM. He supervises graduate students in 2 graduate programs, Mathematics Education in Rio Claro and Teaching Processes in Rio Preto. His research focuses on the nature of aesthetic mathematical experiences using digital technologies, including the communication of mathematical ideas through computer-based performance arts. He's been awarded for research excellence at the 25th Annual Western Research Forum at the University of Western Ontario. And he was an associate editor of Bolema and the Fields Mathematics Education Journal. So with that, I warmly welcome Ricardo Scucuglia for his presentation, Computational Thinking in Humans with Media, Blocks, Fractals, and Music.
Hello, everyone, and thank you, Sarah, for introducing me. I'm going to share my screen. Just a second. So here we go. Actually, I would like to thank all the organizers, mainly Chantal and George, for inviting me. I would like to acknowledge all the institutions I'm part of within UNESP, mainly the grad program in math education, the grad program in teaching processes, and a very special thanks to the research group GPIMEN. I see many members of GPIMEN are attending this seminar, so hello everyone. I would like to acknowledge the agencies that have been supporting the research I'm involved with. So CAPS and CNPq from Brazil and SHIRK from Canada as well. So the agenda for today is, just one second, I'll take the time here. Okay. The agenda for today, I will be sharing 3 episodes, 3 cases, 3 pieces of research. And as the title suggests, the first one is about blocks, second one about fractals, and the third one about music. And they are all related to computational thinking, okay? So that's the way the episodes will look like. And in fact, these episodes, they have specific aspects, frameworks, results. Somehow they are different, but there are 2 theoretical views that work like a core framework. So the very notion of humans with media and the very notion of aesthetic mathematical experience were used as a framework for all these episodes. And in particular, in all these episodes, we developed teaching experiments with different groups of pre-service teachers. So first, about the notion of aesthetic mathematical experience, it's based on the work developed by George Gadanidis. Back in their 2003, George and Cornelia Hoogland already talked about the importance of aesthetic views for mathematics education, and more recently, Gadanidis, Hughes, Borba, they proposed in a paper in 2016 a view that, a model actually for mathematical education reform based on aesthetic views. So in general, I would say that aesthetic mathematical experiences refer to the interface between the use of digital technology and the arts, and in particular, an interface between computational thinking and aesthetics. I think this image represents the several trends of research that I'm involved with currently, and all these trends are based on the notion of aesthetic mathematical experiences. So within this perspective, we have worked with music production, origami, arts-based research, video production, the use of history of mathematics with Geogebra, etc. But for today, I will be focusing on these 3 trends, okay? And which refers to the 3 episodes I will be talking about. I also would like to highlight the notion of humans with media, which works as a core framework for all the episodes. And this view was originally proposed by Borba and Villarreal, Marcelo Borba and Monica Villarreal, in a book published in 2005. So that's one of the most important books in my life. And I think there are many ways to state this view, to state what humans with media means. And one way is to point out this view is technology shapes the production of knowledge. It's more like technology is not neutral when we are producing knowledge. Another way to state this view is knowledge is not produced only by humans, but by thinking collectives of humans with media. And it also related to our interest in investigating process to think with paper and pencil, think with Geogebra, so on and so forth. And then some of the most famous examples on humans with media is when we compare like thinking collectives formed by, for instance, students with paper and pencil to explore or investigate functions, and another thinking collective based on like students with Geogebra, let's say, okay? So in the first case, with paper and pencil, it's kind of fine if we, like create a table, then go to the Cartesian plan and make some coordinates and, like draw the curve. But if you get this problem and just bring directly to the use of software, it kind of doesn't make sense, or it's what the literature has called domesticated. So what is suggested to do, what this view suggests to do, is to use the resources offered by a new media. So with software like Geogebra, we can explore multiple representations of functions, we can simulate, we can, so the nature of the problem, of the mathematical problem, when we use a new media can be different. So the argument is that students, the collective of students with paper and pencil are different of collectives with students with Geogebra. And we can use the same arguments for, like students with Logo and students with Scratch. And I think this view help us to define and to transform our research question in more specific questions. So I think generally we have asked, how do students with media think mathematically? And more specifically, how do students with media think mathematically, computationally? And be even more specific, how do students with media think mathematically, artistically, computationally? So in all the cases I will be sharing, teaching experiments were developed. I'm not saying that all the research activities we do is based on teaching experiments, but particularly in these three cases, we developed several teaching experiments. And by teaching experiments, we mean a teaching and learning session with a small group of students, 2 or 3 students usually, and the researcher plays a role as a teacher during the experiment, okay? So I think this is how our teaching experiment sessions look like. So here we have a pair of mathematics majors, first year, right, undergrad students, and they are exploring like fractals with the Geogebra. So we go and record the session with a video camera, plus we record the computer screen, the screen of the computer, and it looks like this. And then we also captures the webcam image and sound. So beyond the recordings, we also create field notes, and we also use as data students' notes. We elaborate a task, apply this task to students, and they used to write down some notes, and these notes are also part of the data. We have used a model for video analysis in a paper published by Paulo and colleagues at Bolema. So here is an invitation for everyone to visit Bolema's website, check this journal, and also if you have interest, just submit a paper to Bolema. So here we go, first episode. The first episode is about blocks. And it's based in an app designed by George Gadanides and Chris Yu. And in this episode, we share these ideas in a paper published recently. So beyond this core framework on humans with media and aesthetics, we try to develop in this in the framework for this paper, I would say a relation between computational thinking, then constructionism and problem solving, plus related to constructionism, we talked about the learning spiral proposed by Valente and the heuristic process proposed by Schoenfeld. So, and in this case, the teaching experiments were developed with a group of grade 6 students and also with math majors. So the theoretical framework looked like this, right? As I said, we brought up conceptions on constructionist perspectives, and we related that to the learning spiral from Valente, and we related this to problem solving, and we brought up the heuristic categories proposed by Schoenfeld. So the learning spiral proposed by Valente is more, it's formed by 4 main steps or 4 main stages. The first one is description, is the input in the computer. So it overall represents a student-computer interaction. So then we have the execution, that is what the computer does. Then based on the output, we go through a reflection and debugging for a new description. So these 4 steps, they work as a spiral because we usually have new descriptions and a new beginning of this process. And what we did was we make a direct relation between these categories of learning spiral with the categories of heuristics in problem solving proposed by Schoenfeld. So the framework looked like this, a direct relation between these categories and these categories. And from this study, I want to, before sharing 2 main results, I want to show and I want to share the resource we used, the app we used. So here is, let's see. First, I would suggest to visit George Gadanides' website. In this website, you can find many applications, tasks, resources, so on and so forth, and they are related one to another. And in particular, for this study, we use this application called repeating patterns. So the task elaborated to explore this application is formed by 4 parts. Yeah, right. The first part is about engaging students in getting familiar with the code, with the app overall. So the app runs like that. okay? So in the first task, students, they have just to get familiar with the code, get familiar with the comments, change the comments, create new, construct new objects, so on and so forth. But I would call the attention for the artistic static elements of this application, because we have shapes, forms, we have colors, we have sound. So all these elements are important in terms of what we are producing here, okay? So the first task is just about, not just, it's more about engaging the students to get familiar with the application. The second task is about running two codes at the same time, okay? So I can run all codes here and it will look like this, okay? So here we have many codes running at the same time, and the activity so we have many codes running at the same time, and students used to play with this kind of simultaneous codes. The first task is very important. The first task is about exploring nested loops. And it's when you have like one repeat comment inside another repeating comment. And here we change the dimension. We go from linear to two-dimension kind of object. And the third task, the last task, which is the one we explored in the experiment, they look like this. So I will go back here now. So we provide students this code, and then we ask them to create this code, okay? So basically, this last task kind of comprises all the previous tasks, because you have to be familiar with the codes, you have to combine codes, and you have to use nested loops as well, okay? So the two main results I want to share about this study is, first, the way we organized, the way we analyzed and shared the data regarding the constructionist view, regarding, in particular, the learning spiral view. And it's, we organize like this chart, and it's more like it's coming from like a description and execution, and it's kind of the two last parts of the spiral, okay? So we have a reflection and debugging, and it's represented by the dialogue between students and the teacher or the researcher. Then this is the new description of the students, and then this is the execution. Then based on this, there's a new reflection and debugging for a new description, and finally they get the results, okay? So another thing that I think is important to highlight is this problem. There are many ways to solve this problem. There are multiple solutions for this problem, and most of them is more like, let's suppose we have to create this bottom object, and we can start from here, from the top to the bottom, and from the from the left to the right. So here we have like blue, yellow, yellow, blue, blue, yellow, yellow, blue, right? And the angle is, we have to configure the coordinates, the original coordinates, and then the coordinate within the loop. Plus we have to change the angle, we have to change the sequence of objects, their colors, right? So we can start here and go like this. We can start here and go from the right to the left and then to the bottom. We also can start like here at the bottom and go from the left to the right and go up. And we can start here. So there are at least 3 ways to solve this puzzle, right? And in the different experiments, students explore this kind of different solutions for this problem. So the second thing I want to highlight on the results is how we organized this in terms of problem solving and heuristics, okay? So based on the work of Schoenfeld, and, we create a timeline and we analyze which heuristic process would be involved. So this timeline is more about like, I would say about 10 minutes. And the second one is about 40 minutes of the experiment. And then we can see they go through different heuristic processes, okay? So sometimes they keep in one process for a long time, and sometimes they are very quickly changing the process. So that was the first episode about blocks, okay? The repeating patterns application. The second episode is about creating fractals with Geogebra. And in this study, this was actually thesis created or published by Lara Barbosa, who was one of my master's students. And what Lara did, firstly, in terms of framework, I think it was very clever. She looked into the literature and she realized that the term, the expression related to computational thinking changed a lot. And then she picked up 3 of these views. And the first one is about skills. So the skills for computational thinking are proposed, for instance, by the International Society for Technology and Education and the Computer Science Teachers Education. So these are all the skills: data collection, data analysis, and so on. There's another view by Brennan and Resnick, 2012, which is about the concepts, right? So it's not, they don't use the term skills, but they use the term concepts. And here are the concepts for computational thinking, of computational thinking proposed by Brennan and Resnick: sequences, loops, etc. And Gandanides, 2017, uses the notion of affordances. So the affordances for computational thinking are agents, axes, etc. So what Lara did was she comprised all these views. She comprised these notions of skills, concepts, and affordances. And she came up with the term aspects, right? So she proposed 5 aspects for computational thinking, and they are algorithmic thinking, decomposition and generalization, patterns and abstraction, representation and automation, and then evaluation. So for her analysis, and then she worked with first-year undergrad students in mathematics, and I think it was really interesting the fractals that she decided to work, and she created one task for each fractal, okay? So here, from the Sierpinski triangle, for the Sierpinski carpet, and then you also have the Sierpinski tetrahedron, and then the mange sponge. So from here, horizontally, you go from triangle to square, and vertically, you go from 2D to 3D, okay? So the way she analyzed the data was also about creating a graph for the timeline, but instead using like the heuristic components of problem solving. She used those 5 categories she elaborated based on the literature. So, and she also make a distinction in terms of colors. So I would say that blue is like general actions. So one action, for instance, involved 3 aspects of computational thinking. And she decided to highlight, for instance, colors like in yellow is when the students create a new tool with the Geogebra. In orange is when students create a slider tool. And in red is when it's more than 1 minute. So each spot here has 1 minute, but in red is about like 8 minutes because it was the time students were kind of hiding the objects in Geogebra. And this kind of chart, there was an influence from Schoenfeld's work, but also from Dr. Michelle Wilkerson. I remember when I attended the seminar, the symposium on computational thinking math education in 2017, and she presented this kind of graph, and I said, wow, and we decided to use in this research. Something that Lara emphasized was fractals. The conceptual nature of fractals are kind of rich to explore computational thinking because several of the characteristics of fractals, like self-similarity, are important for computational thinking, like patterns, loops, and so on, okay? And then I think another very important result is she worked with 4 pairs of students and they came up with different solutions. And some students, they proposed a solution for creating the fractals. And the type of the solution I would call like by hand. So they created stage by stage, interaction by interaction with the Geogebra. But some of the students, they use one tool from Geogebra called the homothetic tool. And it was very important to use this tool in terms of automation, right? So they kind of facilitate the way to generate the fractal. And finally, and I think it's important I mention is the students create GIFs of their fractals, and we can create GIFs with Geogebra since we use the slider tool. And what the students did, they shared their GIFs and their constructions online. So I think it's important because students' mathematics went through beyond the experiment. So it became like online, it became public. Okay. I talked about the blocks in the first episode. I talked about the fractals in the second episode. And now I'll be talking about the music production. Just 1 second. Here are some of the publications. We talked about music production already. This book in Portuguese, I like this book a lot. The Faces of Digital Technology in Mathematics Education. And there we kind of propose 4 phases for the use of technologies, digital technologies in math education. And at that time, the use of arts was a very important aspect of the current phase. And generally, and this representation is a kind of pedagogic approach, pedagogic view, okay? It's more like, for this cycle, we have been using a lot of references from George as well. So, but basically, what I have been doing is in different courses that I used to teach, can be a knowledge mobilization course, can be undergrad classes, graduate classes. In certain moment, I kind of do this, which is we start with an investigation and we use technology, we use problem solving, we use games, and then after a while, sometimes it's after 4 hours, sometimes it's about after 16 or 20 hours, I ask students to write poems about what they learned and what they felt. Okay, and George has shared a lot of this perspective as well. I was inspired by him to propose this, and then based on the poems, we have created songs, math songs, and after creating the songs, which represents like the songs are kind of artistic representations of the collective thinking in classrooms, we go and we share the song online in social media and so on. It's the same effect of the GIFs online, and it's bringing students' mathematics from the classrooms to the public. So this episode is basically about this third moment, right? Because I think at the very beginning, I used to create the songs, to produce the songs as a teacher, but recently, I would say mainly after 2015, 2016, I have tried to engage students in this production, right? In producing the song together. And we do have some teaching experiments from this process on how to produce a song, a math song, based on math poems created by the students. So this is how a music software looks like. And the very notion of, I try to propose the notion of humans with music software in a paper published recently. And I think here there are two important aspects to highlight. One is the song, the lyrics of the songs are about math, okay? So that's a math song. But creating, producing a music with music software is also about to think musically and to think mathematically and to think computationally. One of the arguments is that music theory is about mathematics. We have the frequency of the notes, the relation between the notes and their frequencies are about fractions. We have the time of the notes. We have many concepts in music theory that they are mathematical concepts as well. So one example that I will be sharing is how you can program a drummer using this software, and how we think with the drummer, and how we think with the music software. And it's very similar to think with the Geogebra, right? With the Geogebra, we go and we type a function, then we change the parameters, and then it changes the nature of the curve. Here it's the same. I change the parameters, and you see that I will change the nature of the drummer as well. So I will share this. I will create a new project. I don't want to close this one. And I will configure the drummer, okay? So here is, and it's like giving students initial code, okay? Of course, it's a different kind of grammar, but I'll make this to facilitate. Here is the drummer, and the wave looked like this. And here at the bottom, I can configure the drummer, main aspects of the drummer. So I'll start like this, okay? So the wave look like this. This is my configuration, and it sounds like this. So what I can do is this graph, for instance, this is very cool. This graph is about from simple, what the variables are from simple to complex and from soft to loud, okay? So I can here, I have much less than I can about complexity and softness. And I go to the other extreme, and then you see the wave will change, okay? So here about complexity, the wave changed, and here's about loudness, the wave changed too. So now my drummer sounds like this. I have many, many other parameters to change. I can change this, for instance, and you become like this. And just to explain the complexity of this and how many parameters we can change, I can come here and like select the style I want, and I have many styles. I will pick up rock, and within rock, I have 6 different drummers, and I can get one avatar like I will get Max now, and I'll change the drummer, and it changed everything. So the type of the preset of the beats and so on. And now look like this. And we can go deeper, like we can come and configure the drummer like this, the kind of the skin we want, okay? The nature of the snare, so we have different snares, and all this makes a difference. It's a parameter, right? It's like changing the number of one comment of the code or changing the slider to with Geogebra. And let me go back here. And so we have investigated how students think with music software or how students with music software form thinking collective or a collective of humans with media. And in that paper I mentioned, I presented 2 cases. And the first case, it was developed with mathematics majors, and the second one with education majors, okay, right? And what happened and what I presented as a result was the lyrics of the mathematics undergrad students was really deep. So they went through like, they talked about arithmetic progression and geometric progression, and they talk about series, they talk about convergent series, they talk about Zeno's paradoxes, and so on. And for the majors in education, they talk about the place value manipulative, which is called in Brazil gold material, the material dourado. And what I highlight here in this seg with the education, pre-service teachers in education, was how they create the instruments. So it was very explicit how they think mathematically to create a guitar, for instance. And I will be sharing this too. Yeah. So here is a dialogue, right? How they were creating the notes, they were taking decisions about the notes, and they had sometimes a mathematical argument, but mostly the arguments were about a new layer in terms of programming the instrument, and it was about aesthetics. It's about the kind of sense and how it was sounding. I will share this again. I will close this drummer I will not save. So that's the song produced by the students. And if I will, each line is 1 track, and the tracks overlap, and they to create the song, and it's become like more and more complex, and we're changing the harmony of the song. I will show only the bass right now, and the bass sounded like that. Actually, it's like this.
Ricardo, we can only hear the first little part and then it cuts out.
Pardon?
I only hear the first part and then it starts playing.
Oh, I see. It's, yeah, I think it's my connection must be cutting maybe.
It's fine. We're still getting a sense of it. Just to let you know.
Okay. Thanks, George. And here we have the bass, and it was created with MIDI, right? So the MIDI here is like for the bass, it's G sharp, F sharp, E sharp, just E, sorry, and C sharp. And the students would like to create a guitar to overlap with this. So they created two guitars. The first one is this one. And what they did was they just copy and pasted the bass, okay? And then they just changed the parameters like this. So the bass is here. Oops. Oh, sorry. Here. The bass is here. And then they changed the wave. They created more notes, and it sounded like this. I'm gonna show only the bass here, then the guitar will come.
Ricardo, we cannot really hear it.
Pardon? It's not working, it's not...
The sound gets really, really soft after 2-3 seconds.
Yeah, I don't know how to fix it, but the idea is here is the bass line, the bass track. Then you have the guitar track, and they created based on the bass line, and they decided to create a new guitar, which was this one. And here, what they decided to do is, they said, I want this sound differently. So what they did was they changed the guitar overall, but they also changed the time note. And they had to decide if what sounds better, if it would be like 1/4 and 1/8, or 1/8 and 1/16. So all this kind of decision making, which had a music nature, they were also mathematical decisions, right? And currently, what I'll be doing is, or proposing to do is, also using the aspects of computational thinking proposed by Lara based on the literature, and saying, when they are creating a song, a math song, they are thinking about this, not only about the lyrics, but when they produce and create the instruments, they are also thinking computationally for several reasons. So these were the 3 episodes I would like to share. here are some of the references, and I will be happy trying to answer some questions.
Right. Well, very nice. Thank you very much, Dr. Scucuglia, for your wonderful presentation. And it's a very interesting topic, integrating these artistic elements with programming and math and sharing them online for everyone. So we'll start by taking some questions now from the audience, and we'll begin with our panel. So if anyone on the panel would like to ask a question, we'll start there and go ahead and jump in.
I would have a question. So Ricardo, thank you for this great presentation. There was a lot of ideas here through these 3 episodes. I actually have 2 questions. The first one would be regarding the categorization of Barbosa, the framework proposed, combining skills, concepts, and affordances. I would like to know how it aligns or is different from different definitions proposed by Wing, Janet Wing, about computational thinking. I seem to recognize some of these categories, so that would be my first question. And my second question is regarding still in that second episode about the fractals, you indicated that students then posted their gift files to share, I guess, to share with others the fractals. And then you said their experience was more because then they share. So I'm just curious about if you researched that part, what do you mean by is more? What do you mean in terms from a theoretical perspective, if you researched it and how you frame this? And also as a teacher, what do you mean by it is more?
Thanks a lot for the question, Chantal. I will, I probably will be thinking about these questions after the seminar. I think we can find in the literature, about the first question, we can find in the literature other categorizations using about computational thinking. And even when they use sometimes different terms, they overlap, right? So the idea, for instance, about loops, they are present in all the, you can call skill, you can call concept, you can call affordance, you can call aspect, but the very notion of loop or loops will be there. And I would like to say hi to Lara because she's attending here the conference, the seminar. But specifically on Wing, I think she proposed different categories in different publications, right? But in general, that kind of view that is a very complex kind of thinking, and it involves like engineering thinking, it involves like mathematical thinking and other kinds of thinking. So computational thinking comprises all this, and that's one of the reasons it's very complex, and one of the reasons it's very interesting. But what Lara did was, when she proposed those 5 categories, she used many references and many codes directly from the literature. So I think they are kind of complementary. About the second question, also another great question. We have not exactly in this piece of research, right? We didn't research how the impact of bringing students mathematics from the experiment to the public, but in other studies, mainly when we propose the production of videos, and the students go and share online, what happens is they start to talk to people, to family members, to friends, to colleagues about the mathematics they produced. And they say, oh, go there and check my video online or check my music online. So what happens is the digital technology and the virtual environment offer ways to people talk about mathematics in social spaces that they would not talk if they wouldn't share, right? If they haven't shared this. So what we are doing, for example, currently is, for instance, students have produced videos for a festival, for an online festival, right? And then they produce their videos, and they have one video which will be like the most popular, which have more likes. So the students, they make campaigns to advertise their videos online, right? So, and they usually say, oh, so they would talk about other topics. Usually they don't talk about math in social spaces, but because of this, they start to talk about in social regular conversations.
Okay, thank you. Just before moving on to other questions, I just want to say that just received a message from Celia Hose and Richard Noss that they are stuck in traffic jam. Unfortunately, could not attend today, but they will be watching it soon.
All right. Okay, wonderful. So if that's all from our panelists, I guess we'll open it up to all of our attendees as well. So if you have a question, you can either type it in the chat box, or you can use the raise your hand function, and then we'll enable your microphone, and you can ask your question directly that way. So maybe I see one hand up. Do we want to open that one from Joyce Magambello?
Can you hear me now? Mm-hmm. Okay. So thank you for your presentation again. I'm just so much interested with this idea of humans with media, and in fact, the idea that media or the technology is not static. It is some form of agency with the media, and that shapes probably our mathematical thinking, or shapes the or whoever is working with. So I wonder though, if you can talk more, whether this theoretically or methodologically, how do you bring forth this idea of some kind of agency with media?
Yes, that's a great question, and it's a very hard question. I think at the very beginning, talking about the combination, the cognitive engagement between humans and non-humans, it's obviously that is ontologic discussion. It's about what means the being, right? The human being, right? And there are many examples about that the unit. For instance, we see the glasses as a technology. We see the speech as a technology. We see the gestures as a technology as well. So, and in this book, Marcelo Borba and Monica Villarreal, they talk about the history of the separation. So how many philosophical views try to tend to separate humans and non-humans. And I think the word agency is very important, and and I think Marcelo has used this term in some of his recent publications, talking about the nature of the agents of technology. And I just want to share a quick note. We used that music software program I was sharing, and we go and create like MIDI files. Somehow they look very non-human, right? They sound like very some kind of artificial, and they say, oh, that's not someone playing, plugging, and recording. It's about a sampler. It's about something that's coded, which is. But the engineering of the softwares, they have been developed so deeply recently that, for instance, I have one command. We have access to one command in that program called the humanizer. So, and then the humanizer command make like, there is something human here. It's not very, very, I would say, how can I say, they exactly fit. So there's something that sometimes it's a small error or something like this. So, and make the instrument sounds more like human, right? You go and you humanize the beat or the instrument you want to. So, yeah, Joyce, thanks a lot for your question.
Wonderful. So thank you very much. I see also Christian Mercat from France. You have a question in the chat, but you have your hand raised. So we'll unmute your microphone and you can go ahead and ask if you'd like.
Hello, Ricardo. Thank you very much for this very interesting talk. Indeed, producing media such as video, a tune, a poem, a picture, a piece of art is really a great way to anchor in an interest in mathematics. Definitely. Regarding musics, math and musics, do you know about the Lala Lab from the imaginary.org consortium? It's mainly European, but I think they went as well to Brazil. So it's based on the Cinderella digital geometry software. So Lala Lab, have you heard about it? And I really, so I put in the chat a link to it. So it's a great thing. Thanks again for your talk.
Ricardo, you are muted.
So Jesus, thanks a lot for your suggestion about the reference. I'll be checking out for sure. Yeah, thanks.
All right, thank you very much for sharing that. Yeah. Okay, and I see one more hand up from Jesus Enrique Hernandez. Sorry, your last name is cut off there, but we'll go ahead and unmute your microphone if you'd like to ask your question.
Yeah, thank you. Thank you so much. Thank you for your presentation, Ricardo. It was awesome. I have only one question here, and it's kind of about the episode 1 you talk about, and I'm very curious about nested loops. You told something about loop. It's a big idea and a hard idea for the students. But in this episode, you use nested loops with them, with the students. So I'm very curious how they use and how they get the idea of nested loops there. So maybe you can elaborate something like about that. It would be great. Thank you so much.
First, my apologies. I said, I thought it was Jesus that was talking the last question, and it was Christian, right? Sorry about that. And right now, thank you, Jesus, for your question. And yes, and what I see, at least in these several experiments that we are doing with the students, is that the younger students, mainly the younger students from Canada, they don't struggle with that. They go and they kind of use nested loop like naturally, something about. But what we found in another paper that we published was like some older students, they struggle a lot with the nested loops. And what they try sometimes, they make a lot of experiments, and it's more about trial. And then, and what we see is when you try and you try and you try a lot, is that perhaps you can like fine tune about how to think with, because sometimes they go and they just drag one repeat command, which is the loop, and they go and run and it doesn't work. And then they try to make a loop inside another loop, and then they run and it doesn't happen what they want to, but they don't figure out sometimes exactly the relation between the role of the loop within the code and then what's happening with the object. So I think one way which is important is that's more like a guess, but I think younger students, they become somehow more familiar with kind of algorithmic thinking. And I think other thing is important is since it doesn't work exactly how you want, and you don't obtain the object you want, you have to think with the code, right? And then try to figure this out.
Okay, that's great. Thank you so much.
Okay, wonderful. Are there any remaining questions?
I would have another question. I don't see any other hand up, if I may. So Ricardo, among our attendees, we have many elementary and high school teachers and leaders. I'm wondering if, based on your work, the 3 episodes now you just presented, would you have any recommendation for the classroom implementation from maybe a teacher that would like to introduce, implement somehow these activities for a first time, more in terms of programming or computational thinking in the math classroom, or even for a teacher that has been doing it for maybe a few years already?
Thank you for your question, Chantal. And I think that's a challenge, actually, right? It's at least 2 reasons why I said that that's a challenge. One is the experiments. In the experiments, we work with a small number of students. So that's very, very different from a dynamic that usually in Brazil we have 35, 40 students within a classroom. So that would be a challenge, right? So mainly because usually the students who are attending the experiments, they have interest on that. Some, for different reasons, they can be interested, but they want to, right? And sometimes in a classroom, it doesn't happen like that. So sometimes the students, some students are not interested in a specific topic, so the challenge would be even more difficult. So the number can be, but it's possible to plan, right? And sometimes work with triples of students, like groups of 4 students, and explore this technology. And there are ways to have 2 different environments, and sometimes students in the classroom, sometimes students in the labs, or we have a lot of mobile technology now. So, and we can have different configurations of the connectiveness in the classroom. And the second challenge is about the curriculum. So how to cover the expectations of the curriculum in terms of content and I would say strengths and processes, right? Expectations of learning. That's another challenge, but I think they don't have exactly to use this activity, or they don't have exactly to talk about fractals or to talk, but they can select one topic, right? And to cover the curriculum content. And the thing that demands like reflection about the teaching practice is what kind of skills will be involved. And more than that, it depends on the student's engagement. So it's about the nature of the student engagement and their with the software that there is a kind of a wide set of skills involved. And but I think it's hard, but it's possible to kind of balance our intentions, our pedagogic intentions, and our educational dreams with the curriculum, with covering the curriculum, contents and strengths.
Sarah, we cannot hear you.
I just noticed. Thanks. All right. Okay, is that all the questions then? Any remaining ones? I think that's everything. Okay, so I guess we've come to the end of the question session then. Thank you very much for everyone, and we'll conclude the seminar.
Okay. Thank you again, Dr. Ricardo Scucuglia, for the presentation today. I would like to thank as well the attendees for today's seminar. We were about 42 in total for today, which is a good number, taking into consideration that it is vacation, summer vacation time for many of us. I would like to invite everyone, please, to take 2 minutes to fill out the attendance survey. You have the URL here, and it will as well be posted in the chat in a minute by Sarah. I remind you that all the recordings, including today's recording and the upcoming seminars information, can be found on the website, in addition to complementary resources that I've mentioned initially. So please visit the website for this information. We have one more seminar to go to complete this seminar series. So the next one is on Friday, the August 28th, at which we will hear from Dr. Paul Drevers from Utrecht University in the Netherlands. He will be talking to us about computational thinking in the mathematics classroom. So again, thank you everyone for being here today. Au revoir à tous. On se voit dans 2 semaines. See you in 2 weeks.
Thank you, everyone.